The first step is to import the STL. Here we have the shock mount shown. We are now going to separate it into different parts so that we can manipulate them. We'll also need to make them into solid bodies in order to join them as components. So here we select them. You see it creates a solid body with a lot of faceted surfaces. Isn't the best to work with, but it'll provide us that good reference geometry that we need to design the mic grip. Next step is to turn all these into components so that we can join them. You might have seen earlier I was right-clicking and pulling up to repeat the step that I had done previously. Here we're creating joints. I am somewhat new to Fusion 360 joints, but it follows a similar methodology as the rest of the CAD programs where you need to select mating geometry. So this faceted surface makes it a little bit more difficult. You see I'm using the plane select as the second mode for both of these. So I select two of the faces. The order in which you select these faces is really important. And also, you can select a point. So we change the angle back down to 0. It looks really close, but a little bit off. I probably selected the wrong vertice here, but I'm going to show how to edit the joint and get it to the right position. So you can see that I have a slider here, but I don't know exactly how far I should be sliding it in order to get it to the correct position. So I use the inspect tool, which you can just hit the keyboard I, and it gets this value. I click on it, it copies it. I go back into editing the joint and type that in as the offset. I like to drag it just a little bit to make sure I'm working on the right axis. So now we're going to go and create a joint for the other component as well. You can see that there's a slight offset, but I think it's going to work all right for my purposes. I'm not sure if this is just the model that has that offset or if it was a problem in the joint, but really we're just looking for the basic geometry and size of this component to design off of. To review, we need to make sure that it connects to the shock mount. It's got a 1/4-20 female thread. It must be removable from the shock mount, and it also can't touch the H1N mic recording device. That's to reduce the isolation, reduce the vibration again through that shock mount, right? We want only the rubber or the elastic material touching the H1N. When I reduce the angle to 0 on this one, it still looks off to me, but using a simple flip, it seems to get in the right position. Now, I saw earlier that this is not in millimeters, when I was adjusting those offsets, so definitely want to set that as default within Fusion 360. Now, sometimes when STLs are imported, there's a scaling problem. We see here that it's 300 millimeters. That's about 12 inches, and it's much too large. I have my calipers, and I was able to measure the actual 3D print, and it was actually supposed to be 30 millimeters. So it probably imported them in centimeters rather than millimeters. So we're going to scale all of these components uniformly, scale factor of 0.1 to be 1/10. Now you see the joint is a little bit messed up. One of them's good, the other isn't. The one that's bad is the one that we set the offset for. So this is really important as we're designing in CAD to make the proper connections and linkages so that when you change one thing, it doesn't mess up our entire model. But when I'm doing these one-off designs, I often write these off just to be quick. This is the quickest way for me to inspect it, move it to the correct dimension. You saw I measured it and subtracted it from the current dimension to get it in the right position. So you can see I created a new component called mic grip. It's on the button next to assemble. I also just turn on capture design history, so you right click on the main component. That'll allow me to go back and change things if needed. We're going to sketch on this back face because that's where I really want the mic grip to be attached. I hit the key P in order to start the project tool. Here I'm selecting geometry that I think might be useful in my design of this sketch. I'm really wanting to design the interface between the shock mount and the mic grip here. So I know I need the top and the bottom surfaces, and I really want the majority of it there. I drew a midpoint line in order to make sure that we have things aligned properly. Now, each of these was drawn as a construction line, so I'm going to select all of them and click the letter X. There's also a button on the right in the little box called line type that we can adjust. So even though I projected that geometry, it's not going to snap and make connections automatically, and that's a good thing. So you saw me use the midpoint tool in order to position it correctly. Now I can just set a length, and the sketch is fully defined. 400 millimeters, much too long. I was still working in the centimeter realm, so just taking a ruler with the completed shock mount and microphone, I'm able to look at how big my hand is, how big the mic is, how much clearance I may need, and something around 200 millimeters seems to be proper. The Extrude tool is one of the most basic tools we're going to use. It's the key E. Now, when we extrude, I'm looking at it, and oh yeah, it needs to connect to the shock mount. So we're going to add that hole back in. I know that my bolt hardware fits well through the hole because I already printed the shock mount part. So I'm going to copy this exact circle. So to do so, I'm going to define a 3-point circle. So I'm projecting 3 points, and then you click Create Circle, 3-point circle, and that defines it exactly the same. I could also go in and project the entire circle, but it's not going to be exact because of the STL import. You saw me go back into the Extrude tool and deselect that area so it doesn't extrude it along with the rest of the bar. That's going to be the backbone of this device. Next up is creating the grip portion of this. So I'm going to sketch on this bottom face, and I'm thinking something like 1 inch squared or a circle with a diameter of 1 inch is going to be appropriate. So 25.4 millimeters about. It looks like we're already at 24 millimeters wide, so we're going to use that dimension. And I also want it to be on this side just to adjust for the CG. If this is sitting up vertically and the H1 end is mounted in there, I want it to have a little bit of weight and floor area so it can sit in that area. I checked the dimension just between the bottom of the mount and the feature I just put in to make sure that my hand, as well as the 3D printed parts, will clear the microphone device again to create an air gap and isolate that microphone. You see I adjusted back down to 24 squared, and we're checking that gap again, right? We want to create a profile just to reduce the stress rise that we would potentially have in that corner. We don't want, just a jagged straight up. So we're going to create a nice spline here. I select 4 different points, and I'm going to make these lines tangent. So these little control lines, we can hit the parallel button with the reference geometry in order to get them nice and aligned. And from here, I can really fine tune and adjust the shape. Not too much of a rhyme or reason to which shape I select. It really could be anything, but making something nice and smooth will again reduce the stress risers that we'll potentially have. That 40 millimeter figure was also measured off of the device that I have physically. So, a pair of calipers or a ruler is something I always have on my desk in order to look at things like that when I'm designing them. Again, the Extrude tool is used. We can go through all in order to make sure that if there's any updates to the width there, it's going to continue to do that. Now, a square isn't the best shape to hold on to. It does have some grip, but I really want to make sure I can hold this for a while and it's comfortable. So what we're doing is we're sketching on the end of the square here. I've projected just the geometry that created that first extrude on there. And a little bit of this is freeform, right? I'm kind of thinking about it. It needs to have a flat surface. underneath. So that's where I kind of start, how wide does it need to be, but also, have round edges. If I just created a circle extrude through this, it wouldn't be able to sit very nicely, on a table or a flat surface. So we're creating a spline again, kind of like we did last time, in order to round it off in a just a non-circular way. The fillet tool will just create a basic, circle radius on it, but this is a compound shape with a flat surface underneath. Now, I think the top, we can get away with a circular shape, so I'm going to draw that right there in the middle of the square. We need this spline geometry on both sides of the component. So next thing we're going to do is mirror it once we're happy about where it's positioned and what the look is. After that, we'll extrude away some of the features. And, as I'm narrating this in retrospect, I think there could have been a better way to design this. The order of operations could have been different. We could have created this sketch first, extruded it as a positive shape all the way down, and then cut away some of the pattern that we see here. And that would have been a couple less steps, right? Right now we have 3 different, going on 4 different extrude features, whereas we could have had 2 so far, maybe 3 with the hole in the back. This shape alone is very attractive. I think in some ways the objectives that we set out to do to have it connect to the shock mount was already accommodated within this, but this is where I kind of let the scope creep get to me. I want to create a pivoting section of this so that I can set it down on a desk at a variable angle, as well as, create a larger footprint on the desk so it can sit up a little bit easier. I'm not convinced that, if I set this down, if the CG is going to be right with the H1N, it might topple over forward. So, what I'm doing here is I'm trying to figure out where I want to put this rotational axis. I don't really want it to get any longer. I think the length measurement that we took earlier is valid. So I'm creating this circle to kind of cut away some of the bottom of this shape in order to kind of indicate to the user, that it can do this feature where part of the handle will rotate down in a way. And this will be a little bit more clear as we go on. But right now, as I'm designing, I just know I need to create a pivot point. And here I'm kind of debating what size to put this in. Should I put hardware through? And I decide that 10 millimeters is a good size because I can 3D print the pin that goes in there. What that affords me to do is to modify the fit a little bit. I don't think I'm going to create any sort of locking geometry on this. I'm going to rely on a little bit of the friction of the plastic surfaces to hold the position of the mount. Next is the somewhat tedious process of kind of cutting away these 2 parts. I want it to still look the same and have the same profile, so really I need to slice and dice this part in order to have 2 components, one that rotates away and one that remains and lifts the microphone, right? So I'm creating a spline where I think the cut line should be. And I'm keeping in mind that essentially it's the top and the bottom piece here. The top of the spline will be one part and the bottom of the spline will be the other part. So we want to make sure that there's a relatively consistent thickness throughout so that we can make sure the part is nice and strong. And also we want to reduce stress risers. So kind of creating that curved shape accommodates that as well. Now, coming straight into this circle, we'll create a stress riser certainly between the 2 parts. So we're going to come back and fillet those later as we cut this part. The next feature we'll do is an offset. So this is essentially how big do we want the cut. There needs to be some clearance between the parts. They could be printed maybe exactly the same, but I use a 0.5 millimeter offset just so that there's a little bit of room for play. If the axis isn't perfectly aligned, that's all right. Here you see I try to go to extrude, but there's a little bit of a gap there from the offset tool that I used. So I'm going to go back into the sketch. I double click into the sketch, I press the L tool for line, and I just draw out that little extra line. What might be better, what might have been better is modifying the spline in order, so it's just one component going in there. You'll see later that we need to delete those faces. But I'm going to grab that profile and extrude it all the way through the part. Now we still only have one piece, right? There's just a cut line through part of it. So we need to now go and figure out where we're going to cut the part otherwise. I want to cut it from this side though. So I create an offset plane, and we're going to kind of go up and around this circle as the cut line. Again, another offset. I like to keep all the offsets the same dimension, so that there's the 0.05 again. And we need to create some lines so that it doesn't cut all the way around the circle. It only cuts the portion that we want. So we're going to grab some of that reference geometry, pull it over, and use those to kind of bound where we're extruding. This line is a little bit arbitrary. Could be anywhere. But now that we grab this, we can cut it directly to the center. Still, it's only one part, right? It's not exactly cut across. So I'm going to go in from this end piece and kind of slice it in half. It'll be, the right side of it will be one part and the left side of it will be another. And we're going to try to go up to this edge there, projecting it so that I have it as a reference. I'm going to draw a rectangle with a width of, you guessed it, 0.05 or 0.5 millimeters, sorry. And we want it to be the entire depth. So we're just going to drag that down and provide a dimension. Probably the right way to do this would be to project the bottom plane there and connect it as such. But we're just going to extrude it right through. Like I said, I'm trying to design this quickly, right? If I were to design this part and I expected a lot of modifications, maybe I would design it a little bit differently so that the geometry is a little bit cleaner. So it's easier, it's better to be modified. But the way I'm planning to design this is to just print it once. I don't want to have to go through this multiple times. I don't want to waste the plastic of a prototype. While this is Proto-Earth, sometimes you really want the first one to work well, right? The first prototype. And in this case, I really only have a need for one. Perhaps, somebody else will print this design and I'll put it out there for download, or perhaps as a product that people could use. But really that's, if I'm happy with the design and it prints well, I shouldn't have to redo this work. Here you see I'm trying to cut back from the other side now. And this is really where the two parts are going to start to separate. Still a little bit hard to conceptualize. Admittedly, it took me a couple times to get to this point. So, you're not going to get it right the first time. You're going to have to test out different sketches, different methods of slicing and dicing this. And, in retrospect, I could think of a million different ways or different order of operations to do so. But, as I'm watching it, I hope that the logical progression of what I'm trying to design and how I'm trying to design it follows. So here you see I created a sketch on this middle plane, and I'm projecting the shapes that I kind of want to fill in. You don't want that cutaway that's kind of left over in there. So I projected them. Now I'm going to extrude them over. But this creates another problem. On the bottom, it's probably all right because it's a flat surface. But on the top, we had that circle profile. So an extrude doesn't follow that shape. So on the bottom there, you saw it disappeared. But on the top, there's still an artifact. And if you zoom in really close, you can tell that there's a little bit of a lip there. Not the cleanest design. So we're going to try to go through and fix that. Now, I think you could delete that face potentially through modify, delete, and select that face. But what we're going to do is go through and try to use that back sketch You see I'm toggling the visibility on the left with those little eyeballs. And I found the sketch I want to use, and I'm going to extrude it through. Now this was a little bit peculiar. I would have thought that you would have intersection. I'm using the cut tool, and it seems to not want to intersect that part. It says that inconsistent information in vertex and co-edge attributes. What that kind of sounds like to me is that you may have a situation where the solid parts just come together and meet at a solid line, and realistically that connection of just a line, not necessarily like a rectangular connection, is not possible in the CAD space. So that's probably what's happening there. So how else can we potentially get through this? You see me scanning the part. It looks pretty good. It looks like it's going to rotate well as nest into itself well. So what I decide to do is to go back into that sketch 7 and create a kind of a flat top to it as well. That'll cut away some of that material. The problem with doing this, you see sketch 7 and all the other sketches have been removed underneath it as we're modifying it, as well as in the bottom in the capture history. All of those were grayed out, and that means that all of those other components are potentially dependent on that geometry. So as we go in here and modify the extrude, so it cuts away that top piece as well, we're going to throw some errors. Sketch 12 presumably referenced that top surface that we just cut away in sketch 7, and you can see on the bottom there as well there's a minor inconsistency. So we got to go through and fix it. This is really what we deal with as designers. If we don't define our sketches well enough, or if we delete geometry that we reference later on, we're gonna have to go in here and repair things. So what I really want is this interior circle to be tangent to this edge, and there's multiple constraints defining it. The lines are in black, which means that they are fully constrained. So as I try to create a tangent, it doesn't want to let me do so. It has other references it needs to maintain first. So I'm going through, I delete some of them in order to see if those will help me. Skipping ahead a little, I end up finding the problem where this point was defining where the center of that circle needed to be, as well as it needs to maintain tangency to the top edge. So I was able to finally get it tangency to the bottom. But lo and behold, that also messed up my extrude feature. So I need to select the proper components and portions of this sketch that actually need to be cut away. This is what happens when we mess with the constraints. But it's not really a problem. It's just something that we need to manage appropriately, as we're creating, or deal with the consequences as you see here. So that looks a lot better. We've got a somewhat flat top. We've got these cutaways. Looks like we didn't go quite far enough here. So when I select the sketch, it kind of has a little icon in the bottom capture history that shows me where that feature was defined. So that's how I'm often able to find these sketches that I need to go back and modify. The next step is creating the pin. So I'm creating a sketch kind of here at the midplane. I'm going to project this circle. For reference, I'm going to use just a slight offset on this. I could use a circle tool, but this is better find. I find that an offset of 0.1 is a great one for just a slight press fit. Components that fit well together with 3D printing. There's natural variation within a 3D print. So if I wanted to create it like really press fit, something that I had to hammer in, I'd probably use 0.05. But yeah, in this case, I'm going to use 0.1 because I do want it to be able to rotate. And After installation, I probably could have gone a little bit smaller in that dimension. It does hold its position fairly well, but at extreme angles when gravity's working against me, the rotational axis can move by itself, right, with the force of the microphone and the weight there. So creating an extrude, I'm going to go a little bit past the extremities on both sides so that I can cut it back to the proper size. Probably could have gotten away with just creating a straight extrude, but to keep things clean, we're going to try to do so. You see here, I try to select out to an object before, but it doesn't really have anything to touch, so that feature doesn't end up working for me, and I settle for again just kind of cutting away the extra geometry. This really aligns with like subtractive. It makes me think of like subtractive type manufacturing methods where you've got a bar stock and you need to cut it to the right size. I think when I model, I do this maybe a little bit too much. At the end of the day, we are using additive manufacturing. So we should be able to think about it as just the positive shape. Most of these shapes that I've created here in this final sketch, again, could have been created with a lot less features, and it would be a lot easier to go back in and modify if I had done so. But we're creating a sketch here on the end. In order to cut away, I'm using, again, the project tool, shortcut key P, to create those features. And I'll just create an arbitrary rectangle somewhat around this so that I can cut away all that extra geometry. We'll use the extrude tool to go back and cut through this. Now, if I was touching multiple objects, I'd want to go into that objects to cut tab within that extrude feature just to make sure I'm only cutting the pin object. So it looks good. It looks like the pin's in there properly. I think the only thing left to do is to create these stress reducers, really fillet these different areas. It's good to inspect the part, make sure that it's 3D printable. I'm seeing that there's a significant undercut on that one that will require support material, as well as a little bit of waste. So I think I could have designed it better so that it could be 3D printable from an FDM printer. There can't be unsupported arches or edges. Here you see I'm deleting out some of those extra little extraneous faces so that I can create a fillet. You just go into modify and delete and select a face. I think I really like this about Fusion 360. It kind of breaks some of the sketching references, which isn't the best, but it does allow me to go back and smooth out a part like this. So you see there's a little extra geometry there that we don't really need. Delete. We're going to match the radius. It was 10 millimeters on the previous one, and we'll go to 10 on this as well. Those pesky edges just keep getting in the way, though. We really need to be better when we're creating our sketch geometry. If you remember back, we were creating those splines, and we created little lines to offshoot them, to extend them into that circle. And that's what's really creating, again, not too big of a problem, just something we have to manage now in the future. So we're going to create fillets on this one as well, just to reduce that stress concentration that would be caused by that straight edge there. As well as it looks cooler, if you ask me. So we'll use the same geometry. Symmetry is always good. Bringing this back down all the way to 10. And at this point, I'm fairly happy with the shape. It looks really clean. We're going to do a last inspection before we send it off for 3D printing. To 3D print, click File, 3D Print. You select the part that you want to create an STL with. I like to use the high refinement. I've got plenty of storage on my computer, and really this isn't too big of a part. So we're going to go in and save each one of these files. You'll see I already saved off a file. I hadn't created the fillet the first time I exported these. But it's always good to keep with just a general naming convention, something, so you can tell what the files are, outside of it. So I've named them main body, pivot body, and pin V1, just in case I need to iterate this. But fingers crossed, it should work for us. And spoiler, I'm holding it right now, and this design did work out really well. So we'll show that here at the end of the video. This is where I kind of get into some, again, scope creep. I didn't put in my requirements that I wanted it to be grippy, but for fun, as a 3D printer would, we can add extra features for free. So I'm going to create some little what are called spikes, I think, in this program. This is Mesh Mixer, another free program that you can use. We're going to turn on symmetry so that it's the same on either side, and create some little spikes in the back of this part so that there's enough grip. Those look a little bit pokey, a little bit small. So we're going to increase the size and go a little bit lighter on it. The sizing doesn't have to be, it can be pretty arbitrary. The positioning can be pretty arbitrary. I'm just turning it around to make sure that I'm not modifying any of the faces on that backside there with these parts. While that kind of looks fun, I think I'll just go for a straight line in order to make it look a little bit cleaner. Given enough time, you could create a really interesting texture here. In Fusion 360, we could also go through and potentially knurl this part, creating revolves around the part in a spiral. But this is a lot quicker, and I think it'll provide little mounts and grip points for my hand, whether I'm wearing a glove or just to make sure it doesn't slide, out of my hand. So we'll export this again as an STL with a good name. Finally, we're in Cura. This is called a slicer. It creates the program for the 3D printer, and it has a variety of settings that you can modify for the 3D printer. So I'm going to import all this geometry. Right click on the bed, arrange all models, kind of separates them out. I've got this auto orientation extension. You need to select the parts for it to work. So here I go, holding down Shift as I select all the parts, and auto orientate. So it looks like it did two of them, the pin and the pivoting part, really well, but I think it properly addressed this part where it says that there's going to be a lot of overhang whichever way you do it, unless it's like kind of vertical like this. But realistically, you're not going to want to print this high. You could deal with bed adhesion problems where it would topple over and not finish the print. You could probably support it, but it's also going to take a lot longer. The Z-axis is really what takes a lot of time on a 3D printer, because it has to build up each one of those layers individually rather than just moving smoothly horizontally. So we can select a face to put it down on, and then arrange again. And the red indicates when the overhang angle is breached. So all of those fillets that we put in and those circular features do have somewhat of an overhang. So we're turning on support here. We want the support only to be touching the build plate. So we don't really want support within those circle cutout geometry where the pin goes. So we'll do only touching build plate. Next, we're going through all the settings. We have 4 walls, which is a primary contributor to the strength, as well as the infill density. So here I think 30 to 35 is actually pretty dense, especially with 4 walls. So that should be strong enough for non-load bearing parts, potentially some load bearing parts. This will hopefully last a while, as I use this microphone. So I wanted to make it pretty stout. But you can see there that the infill has reduced the weight of the components a little bit, and we've got the light blue support shown. We'll measure how much weight that is and how much scrap we end up getting from that. Again, I'm really excited about 3D printing because it has the potential to be a circular material. we could take off that scrap and potentially remelt it back into filament. There's plenty of projects doing so. Although I don't have the tools, there are already companies that will take my filament scrap and turn it back into filament. So here we're going to export the G-code file, and we'll see you on the other side once it's printed 5 hours later.